Lesson 3.2b, solving linear systems algebraically using the elimination method. So this is easiest to explain with an example. So I have two equations written already, and you want to align the like terms and the equal sign. So you can see my x's are aligned, my y's my equal sign, and my constants. And then we want to eliminate variables. So if we multiply one or sometimes both equations, we can create opposites. So if we multiply one of our equations by simply a -1, we can create a -2x and get our x's to cancel. I rewrote my system once I multiplied my second equation by -1, getting -2x plus y equals 4. So now we can add and isolate a variable. So the 2x minus 2x cancels. So we end up with 4y equals 24. Divide both sides by 4. So y equals 6. Finally, we substitute this value, the y equals 6, back into one of the equations. So that's step number 4. So you can see that I took this equation. So we're going to substitute in the 6. 2x minus 6 equals -4. Add 6 to both sides. 2x equals 2. And divide both sides by 2. So x equals 1. So we have y equals 6, x equals 1. So our solution is 1, 1,6. And then we could sub that back into both equations to double check our solution. We'll try one more system together, and I suggest that you pause and attempt to solve it on your own, and then hopefully we get the same answer. We're going to solve this system using the elimination method. So you might want to rewind or check your notes and take a look at the steps if you forgot. So remember, pause the video and give this a try, and then we'll do it together. This problem's a little bit deceiving because it looks like that our terms are all aligned, and they are, but the issue is with the equal sign. So we're going to have to reorder probably the first equation to make it look right. So you can see by adding 11x to both sides, I'll squeeze it in here, it results in my first equation looking like that. Now we want to create opposites. Sometimes we have to multiply both equations by a value to create our opposites. So you might have multiplied by 2 and -3 in order to make the 6 and the 4 equal to 12. Let's use 4 and -6 because 4 times 6 is 24 and 6 times 4 is 24, just so that you can see that we should still end up with the same solution. To the right of the screen, you can see my new form of the two equations. The -24y and the 24y cancel, so we end up getting 2x equals 0. Divide both sides by 2 to isolate the x. X equals 0. Now we're going to sub this into the original equation, one of them, to solve for y. Okay, so I chose the first equation, so we're going to sub in 0 for the x. -6y equals -36. Divide both sides by -6. Y equals 6. So we have y equals 6 x equals 0, so my solution is 0, comma 6. And then you would sub the ordered pair back into the equations to make sure that they work in both of them.